morning, such as mornings are. So this is one of those talks I tend to give every year or two where I'm talking about a topic that I know for a lot of you this is daily bread and butter, but some of you really are in environments where this is new, if only for silly reasons, not for sensible ones. So we are humans, we are tool makers. Since many, many thousands of years ago, or more depending on your belief of time. This is how we get our advantage in the world. Now, I'm more talking about the sort of tool making that is done by a lot of craftspeople. Woodworkers, metalworkers tend to do this a lot. If you go on YouTube and look at tool making and die making videos, you'll see often that in 10 hours of video developing a project, they will have 8 hours of building the tooling, or at least they will have cut out 80% that is building the tooling so that the project is really easy, simple, and hard for them to screw up. And this is the sort of stuff really that I'm talking about. I just need to do a clean cut with a router. I'll just chuck a bit of wood on the side of it and it will do a clean cut. I don't have to handhold it and I'm much less error prone. And of course, in the computer world early on, we had people doing open frame machines and just extending it was a classic part of work. And not so much anymore, but now we have our scripting languages, we work in a software world. So we do tool making for many reasons. I think the most key for me has always been the ability to answer ad hoc questions. Hey, the vendors just said this run of power supplies is liable to explode. Do we have any of those? Because we don't store the power supply serial number in inventory, but it is in the log of this other thing. So if we can just grep through that log, we can find them. And we can use regex and at least go, we've got these. We've also got these nearby serial numbers that we should ask them about, which is helpful. What does this BGP route look like on core routers? Morali, who's speaking later, and I, many years ago, were troubleshooting an issue with load balancing where we were trying to figure out why this route wasn't load balancing. And that's the sort of thing where logging into 20 different routers and getting their exact view of the world and just running diff is really helpful because often you can go, oh, of course, the difference is here, so I need to look exactly here and it'll be that. And with a lot of these rough, quick answers can be incredibly valuable. Being able to know in 5 minutes that we've got 100 power supplies out of our 10,000 deployed machines that might be in this thing, look, it's 100, stuff it, I can just hand verify that list. But going, we may have potentially need a shipping crate of replacement hardware, but we don't know, someone will get back to you next week, not as helpful. And of course, deployment and test are rather more well-known these days with a lot of development engineering work, integrated tests, continuous integration, all that becoming fairly standard. And those do apply for operations. If, even as someone in the networking space historically, a huge amount of my time was spent writing tests for our configuration, making sure that I couldn't come key presses away from breaking our network. And any time I discovered I had come key presses away from breaking our network, then spent the next couple of months fixing that. So they're also really, really helpful as an example for future work. We had this network inventory system that had an incredibly obtuse API. So every time I did something with it, I usually wrote a little tiny experiment that I chucked in this Python file. And then when I was writing real code later on, go back to experiment, copy those 20 lines, modify the 3 things I need. And I know I can use it. It works. And it also builds a toolkit. That little thing of examples was a valid script. And when I was having trouble with our rancid seeming to deliver delayed, well, actually a different system that fed off all horrible integrations, delivering delayed results, I was able to use this collection of things of the inventory system and just went, also print me this field of the data proto. And I was able to very quickly build up, plumb together some things to go, hey, this team, you have a problem. Your frontline human data is saying that's current. Your machine data is saying it's not. I think the machine data's correct. And we write this in anything. We write this in shell, we write it in pipelines and scripts, editor macros. If you've never seen someone like Rusty or Tridge, there's a couple of others that regularly attend the conference that are just Emacs wizards, and you will watch them in 10 seconds do some incredible amount of magic with their editor. That can be really valuable. Of course, maybe you can program it, just not need to. Perl, Python, Ruby, PowerShell, there's an infinite number of languages. Choose one as a primary if you can. Realistically, if you're using Windows, PowerShell should probably be one of them, but maybe multiple. For bigger stuff, C++, Java, Go, Rust, if you are a development shop, then copying whatever language your developers use as primary in that space is sensible. Might not be optimal, but it also means, hey, developers, this is a bit too complex for me. Can you give me a hand? Is more likely to work. Although, of course, reusing standard languages, standard libraries is more sensible. If you're using, I've been told these are outdated examples, but if you're using Puppet, doing stuff in Ruby is probably more sensible than doing stuff in JavaScript and running it through exec lines. Complexity is one of the key messes here, and we'll get into some of the worst stuff later. Keep your shell pipelines pretty simple. I have written on a fairly wide, probably 200 character wide terminal 4-line shell pipelines. They tend to sort of evolve. And as long as they're one-off answering a question, that's fine. If I want to keep it, it should probably be turned into a script. You can write giant shell scripts. One we used to use was with tests, and it actually did have tests, about 3,000 lines. That was silly. You can do them, don't. Shell very quickly gets impractical. And for editor macros, you sort of want a few lines and then just jump out into something else. But for other languages, there really isn't an inherent limit. Do some sensible modularity, actually write tests. If you're in an environment that doesn't do this to start with or can't have you work on an existing toolkit that is actually got tests, this is one of those things that can be a bit hard to learn. Once you get used to writing code that is testable by structure, or at least more easily testable by structure, most of your testing becomes a lot easier. And it doesn't fix every bug or prevent every bug. It prevents a decent chunk of them. There are people that will say, oh, above 100 lines, you really should write it in C++ or Go or whatever. No. If it's above a single core of a machine and it's a permanent job or you've got to run it for a while, maybe Python isn't the best choice. But it turns out for a lot of what we do, that's pretty rare. Often if that's true, there's one or two silly algorithmic things or even language idioms that perhaps you should change. But otherwise, most of what we tend to do, even at pretty decent scale, it's not a problem. I think the worst code I run is this customized version of grep that takes about a minute to execute using every single core of my workstation and a nice grunty Xeon machine. Other than that, nothing I use needs CPU, really. So testing is hard, especially if you've got interactions. If you're doing a deployment system that's going to reinstall a machine, it's hard. You can split elements down. If you test the core, you at least have elements that you can trust. And maybe you don't write tests for the full-on deployment of a new thing. Maybe you don't do it because it is hard. Maybe you just don't do it because you only deploy once a year. You only deploy a full rebuild once a year. And you know what? Something's going to have changed in the process, so it's going to break the first couple of times anyway. And that's reasonable. One thing that is really, really handy, as well as just splitting in modules, if you have standard constant values, that every now and again they change. In the network space, for me, this was like AS number, standard prefix limits, standard TCP keys, a couple of non-security related keys. Sorry, I should clarify. For security keys, there are much better options. Having a shared library for this that's available in all the major languages you use means you go update that and ask people to rebuild instead of trying to grep your entire source base, figure out which ones are the constants you actually need to update and which ones are not, and so on and so forth. This is one of the great fails of our tools. We often write them for ourselves. We know that the third argument is the magic thing that doesn't destroy the world if we provide false. I don't, after lunch. I forgot that I did that. Writing some trivial documentation, bullet points is more than fine. What something doesn't do is often just as valuable as what it does do. If you know that a tool's going to be out of date by date or by project, write it down. That's helpful at the very least for the people working on the new project to know that they're not expected to update it. And sometimes to give them just, oh, we're actually expected to implement this automation we promised. They're relying on it. They've stopped development on this other system because we have promised to replace it. Doesn't always work, helpful. And for input validation, do some. You don't need to make it perfect. If you have a nice, easy library that lets you go, oh, that is a real valid customer number that's actually an existing customer and hasn't been deleted already, sure, use it. This is why your libraries are great. If you don't, maybe you just go, regex says that's a valid number, cast it to an integer, it's within a plausible range, fine. What you don't want to do is accidentally paste your password, have that interpreted as a customer number and destroy your major customer. And you're not building tools for, at least often you're not building them for complete randoms on the internet. You're building them for people with a decent amount of context. So actually just going failed input validation, bail with usage error, completely reasonable. As you maintain these over time, you'll end up making this better and it will bail with the usage error going, oi, customer number's wrong. But if it's the sort of stuff you're building for your own team, worst case, I can dig into the source. And maybe we've added customer number dot subproject. Who knows? Distribution of tools. This is one that I can't even give a generic answer for. Some sites don't run things on your workstation. Some people have bounce hosts for everything. Some people have work hosts in deployments. Some people have through web apps for everything. Some people have desktops. Depending on how you are, what you do depends on how you deploy. One of the key things is try to avoid people writing personal tools for team problems. Because that also means that they're doing it differently than everyone else. If you have to change a process, they won't because they won't remember to. Maybe it's not an update. So have a way to distribute so all the appropriate people can run it and the appropriate people can update it. If only one person can update and they've buggered off on vacation for a couple months, very helpful. So scaling. This is something that turns into a job for a team. And then we've hit the point where the battery's died. So I have worked, and in fact, I currently work at a company where when I joined, the group I joined was not allowed to write software. We solved this by ignoring the rule and writing software. The most common exception I've heard about this is, oh, we allow our operations people to write little scripts but not software. Ignore it. The other one I've gone through was a read-only rule where we could write software that that read production data but never reconfigured things. And that was a great way to demo that we could, and it also pretty quickly demoed that the bits that went wrong wasn't the software, it was the humans that were then copying the stuff the software did, pasted it into the wrong window and promptly destroyed the wrong city. And if you can get management cover, it's helpful. If you can't, maybe just don't tell them. That works in some places. But ultimately, some companies want nice, efficient operations that's reliable. Sadly, some places are empire builds. It depends. If you're a small, medium-ish ops team, sort of maybe sub 20, actually having one, maybe two dedicated, primarily tool-making engineers is incredibly valuable. They can do a huge amount. They still probably need to be on call, or do your standard equivalent of, so that they are solving their own problems. It just means that their projects outside basic on-call duties are building for the rest of the team. But you probably don't want to turn this into a large team of its own. If it gets to the point where you really do need that many people, what you probably want is a team building supporting infrastructure and actually doing the more software engineering-y design that you then integrate. Or have them work on the upstream projects that you're busy writing 10,000 line scripts to automate deployment of because they're so painful to integrate. Maybe we can fix it upstream. But if you build tool makers, if you build separate teams for tool makers, you end up with the people that designed it and not the people that use it. And you see this, those of you that use development tools, you can sometimes tell when they were done by teams actually using their own tools, when they weren't. Anyone who's ever done electronics engineering work, you can tell the tools that have actually had PCB designers ever give feedback. And that was it. I think we've got a couple minutes for questions. And yeah, if you, QTKDE or BGP person, please come talk to me at some point. I have questions and things.
Just a small issue of disagreement. If you structure your code correctly and well, you can easily extend Emacs Lisp to huge programs. My entire mail client's written in it. You know, you can do whatever you want.
Oh, I mean, a bunch of we have, at work, we have a bunch of standard Vim macros that we deploy, and that's probably a couple thousand lines. There is a standard Emacs package, but I unfortunately have to use devices that ship with Vi, and I mean Vi, and that's it. And I'm lucky that they have Vi. They have Vi.
Hi, I work at a team where we have a lot of repetitive processes, and it seems like everyone has their own different ways to solve this problem, and so tooling just proliferates and diversifies, and that's probably not a good thing. Do you have any suggestions for that?
Yeah, that's where building those libraries so there's just a standard way that solves this area really nicely, easily, and is better enough that if I have a half-assed version, when it breaks due to an infrastructure change somewhere, I might just use the shared one. And it is, if you've got that environment where everyone has their own tooling from the start, it takes time and pain, and you really just have to accept that it's going to take a couple of years or human rotations out of team to pick things up. Go research and find the place where you've got, for example, as we did, a documented, you should use this SSH config. It says to use the crypto algorithm 2fish. Doesn't work so well when SSH removes 2fish as obsolete and you break the entire team that you've now got to explain, yeah, that was wrong 4 years ago. And you still find people a month later because it turns out that some of your people don't log into routers every day. So, sadly, build good libraries, it still takes time.
Working in operations, a lot of the automation and tooling that we implement is against very vendor-specific APIs with very vendor-specific responses. Do you have any suggestions for getting started on implementing good tests to emulate that?
So the standard way we tend to do that is just suck it up and write really dumb fake implementations that ideally do some input validation and go, yeah, here's the canned response we roughly expect. One thing I will say, probably don't try to do is there is some level of converting vendor specific into vendor neutral that works, and you can go way too far and try to be more generic, and what you're actually doing is still encoding one vendor's view of the world that will break terribly. One of the classic ones for me in the networking space was VLANs, access security and such. The per vendor way of doing it is terrible in general. But it's differently terrible in such a way that you can't realistically predict. So trying to make a complete vendor neutral one doesn't really work. If you know that what you're using the VLANs for is something, you can structure the way you use it, not completely generic network, and that works. All right.
Okay, maybe one quick question before while the next speaker sets up. No, too late.
Sorry.